Hello everyone and welcome to another episode of Let's Code Duke Nukem, where we aim to recreate the original EGA action platformer, released in 1991. Last time we added some special effects that really add some flair to the game, so today we will add the wall crawling techbot, which behaves like the techbot that we added in an earlier episode, except that it patrols up and down instead of left to right. Other than that, it's a pretty simple guy. You shoot it once and it dies in a puff of smoke, and if you touch it, he will hurt you. Alright, let's go. So let's check out the tile IDs for the wall crawling techbots. So there we go, green bitey creature walking up and down walls. And we have two different IDs depending on the direction that they're facing, right and left. Okay, so let's start by adding the enemy to our enemies package. So we'll call it a wall crawler. And then let's extend active here. And then we saw that they have some sort of a facing. So this constructor takes into account the correct facing, and then let's render it. So render draw tile assets get anim, and then the index was for the right facing creature is 40. So int tile index is facing right 40, and otherwise it is going to be 44 for facing left 44. But it is an anim2, so we have to add 100 to it, so that's 140 and 144. And then of course this guy is animated, so private int frame, and then let's initialize the frame to 0. And then let's say that we want the tile index plus the current frame X and Y. And then I guess we'll just increment the frame in the renderer. All right, so that is the wall crawling graphics, left and right. So they will stay stationary at the moment. Let's first get it inside of our level. So let's see, what was the tile index again? So that is 3016 and 17. So that is here. 3016 is a wall crawler XY, and it's facing right. And then the other one is 17 facing left. All right, let's run the level and see if we can find some green bitey creatures. All right, and we just crashed the game. So let's take a look here. All right, we are incrementing our animation frame, but we need to make sure, of course, that we don't exceed. So frame plus 1, and then we have 4 frames. So yeah. And now we can see these wall crawling bots. Looks like they're falling down due to gravity, so let's apply gravity and let's not do anything. But here we can see the background tile being copied. So this was the original position of this crawler here, and it's copying over this background tile, but because it's facing right, it should have copied over this background tile here. So let's fix the loading of the level to get the correct background tile. So here's the read level. So what we'll do is, because we have to copy over the right tile, but because we're doing it in a loop here, that means that we have not seen the tile to the right yet. So let's first just read in all the tiles. So we have the raw tile data, tiles I equals the read. And then let's loop again. So now we have the tiles. And then let's take the tile ID, it's tiles I. And yeah, we want to save the start location as usual. Then we encounter certain tiles. And we want to copy over the different tile. So here we're always copying the left tile. For the start location also, apparently always the left one, which is fine, but for now. So the left tile is usually the correct one, but in our case, the only tile for now that we have to copy a different one is this one, when we have a right-facing techbot. So let's create a little extra function here at the end of this if, saying we'll just copy over a tile. So here we can say that the int copied tile ID equals a switch on the current tile ID. And then in the case of this one, we want to have the tile that is to the right of this actor active. And in all the other cases, we'll just say like, give us the left tile, I-1. And then here we can say tiles I equals the copied tile ID. So let's inline this. And let's say that we just want to have tiles. And then here we can just say like, give me I+1 or give me I-1. So this means that this will copy over the tile to the right and this will copy over the tile to the left. And then for some other actors, we'll be adding in tiles above or below, depending a bit on the situation, but we'll have to see that per active tile that we're going to be implementing. So then we can remove this one here, and we can remove this. We cannot remove this one because it's in a different if statement. So we'll just keep that for now. So yeah, I think this should copy over the correct tiles. So let's find that crawler at those boxes and see if we still have a weird copied part of a box there. So here this is looking pretty good. And here are a bunch of other crawlers as well, which are also looking pretty nice. Yep. All right, so let's make them crawl up and down. So we'll keep track of our direction. So this is if we're going up. And that is also going to be our default state. So up is true. And then we'll just implement the update function here. Because, let's see, first we want to reverse direction if we bump our head. So we want to say reverse. And here when we land on the floor, we also want to reverse. We want to go back up again. So let's add this reverse method. And this basically means up should be not up. So when we're going up, we're going down. And when we're going down, we will go up again. So that is step one. And then we should check here in the update. Check if solid ground, otherwise reverse. And then we have to set the velocity. So if we're going up, velocity is -1, and otherwise the velocity is going to be 1. So either -1, 1 pixel up per frame, or 1 pixel down per frame. Yeah, and we should, yeah, let's first do the patrolling and then we'll do the other stuff. So if we have reached the edge, so if edge reached state, because we're going to need a level, then we'll just reverse. So let's make a method here. Private boolean is edge reached, game state state. Now, how do we know if we have reached the edge? Well, the first thing is we need to know the next row that we're going to be in. So our next row is going to be our y plus our velocity. So when we're going up, it is -1. If we're going down, it is 1. So I guess we need a method private int, I don't know, determine velocity or something. So Let's just do it like this. So let's add the velocity here and divide it by the tile size so that we have the correct grid row. Now, like the collision detection that we've built, we need to know if we're going up or down so that we check either the top side or the bottom side. So let's add in, if we're going up, then we are already top side because our Y is our top coordinate. But if we're going down, let's add the height of this actor. So this is the next row that this guy will be at. And then our column needs to be our X position divided by the tile size. Plus, you know, these, let's see, do I still have the game running? No, I don't. Okay. Plus, when we are facing left, so if we're facing to the left, that means our feet need to connect to something to our right. So we have to add 1 to our grid position. And of course, if we're facing right, our feet is going to be to our left. So we need to subtract 1 from our grid position. So that is going to be the column that we're checking. And now all we want to know is, are we at a solid grid cell over there? So because if it's not solid, then we've reached the edge. And then that means that we should turn around. All right, so let's see if these green guys are patrolling up and down. So let's see, there should be a few here. So these guys are patrolling up and down until they reach the top side of the box, and then they go back down again. Okay, we need to fix the animation as well, because when they're going down, the feet are moving in the wrong direction. So, and then let's see, this guy reaches the floor and goes back up again. Okay. And then let's wait until it reaches the top. At least if we can see it. Yeah, and then it goes down again. All right. So then that is cool. So we need to update our frame, because we always increment our frame after rendering. But we want to negate, we want to subtract when we are going in the different direction. So when we're going up, we want to add 1. And if we're going down, we want to subtract 1. And we want to make sure that we do not go into the negative. So let's always add 4 as well. So that when we go the other way around, we won't end up in the negative numbers. So this should reverse the legs of the wall crawler when it's going down. Let's go ahead and take a quick look. Yeah, I think this is looking pretty good. Okay, so now let's make them hurt us. And let's be able to shoot them as well. So after the update, let's do a check hit. And let's go to our techbot and let's make them hurt us as well. All right, and then when we hit them with our gun, then we'll set the active to false. And we will score 100 points, I suppose. So state score 100. And we'll add a smoke effect to the creature's XY position. All right. So let's see if they hurt us now. They do, and we can shoot them. That is pretty nice. So with this wall crawler now being able to move up and down, and it's able to hurt us, and we're able to shoot back, we should take a quick look at our techbots that are patrolling from the left to the right, because we've seen that they are patrolling a bit too far to the edge of their patrolling area, and they're moving a bit too fast. So let's take the lessons from the wall crawler and apply them to the techbot as well, and we'll fix also the tile copying that I changed just a second ago because I've messed it up. So let's go ahead to the resource loader and let's see what we're doing wrong here. So first let's take here, let's reduce the amount of duplication. So here we'll just calculate some sort of offset. So look to the right, look to the left, and here we can see that we are overriding the tiles again. We should not do that. We should just do it like this. So if we now run the game again, we should see no more gaps in the level. And yeah, that is nice. All right, so let's see. So our wall crawler just extends active and basically uses the regular super update and velocity stuff. So let's have the techbot do the same. So let's see here. We should do an is edge reached as well. Then we should reverse. So let's add our reverse method. And here we can just say we need to flip around the facing. So where did we do that? That is this guy here. So this should reverse the techbot. And then the techbot should also reverse when it hits a wall. So that is that. And the edge reached method, we should also implement that. Let's take it from the wall crawler and adapt it for our techbot. Now the row is always the row beneath us because we are affected by gravity. So all we have to do is divide y by our tile size and add 1, and that will give us the row beneath us. Now the column is something else. So what we want to do is if we are facing left, we want to look to our left, so we need to check for minus speed in this case. And otherwise we want to look to our right, but we also have to add our width so that we actually look on our right side of our box as well. And then we can divide this whole thing by the tile size. So this should give us the next column. So row next col. All right, so if we hit a wall, we should reverse. Reverse is just flipping our facing around, and here we're checking if we have reached the edge. So here's our update function. So we only want to do this if we are alive. So if we are alive, check for the edge. We only want to do this when the frame is actually 0. So let's do that here. So if our frame is actually 0, check for the edge, possibly reverse. Try move is now done by the super.update. So let's just move that let's just move that here. Let's always do a collision check with Duke, and I guess the update also should happen regardless of the frame. But here we should set the velocity. So if we are facing left, minus speed, and else speed. And yeah, so I think this should change the patrolling behavior of our techbots for the better. Yeah, so now we can see that they are patrolling to the edge of their respective platforms. And let's see if this guy also goes back when it reaches this obstacle. It does. It actually takes a minute for him because he stops for a second. Don't know if you guys noticed. But that's because, of course, they have to finish their animation. We'll check before they move again. So let's see, that is the hit wall. Yeah, of course, that is done after movement. So then it has to wait for 3 frames before, moving again. We'll check with the original game later if that is the intended behavior. I think this is looking pretty cool. So when we shoot these guys, we should also spawn some sparks after the explosion here is done. So let's do that. So where's our hit? So this try move can just go. This render is still fine. So here we have hit exploding is 0. And then here, if we are actually dead, then we'll do state add effect new sparks xy. All right, so we've updated our techbot with patrolling behavior. And we've implemented this wall crawler with some nice patrolly behavior. This determine velocity y. So let's see if we can fix this as well. We'll do this the same as a techbot, where we just tell it to like, hey, you know, take your speed and add your dimensions if needed, because here we're also doing some stuff with height and stuff. So I think what we should just do here is say like, okay, y plus, if we're going up, then this is going to be also a speed variable. Let's just add it here. Private static final int speed equals 1. And let's, so if we're going up, we want to have speed, and our y is already at the top, so that is fine. And if we're not going up, we want speed plus height. And that is what we want to divide by the tile size. So that makes this determine velocity y redundant. So let's inline it here. Let's say speed. So this should be minus speed, of course. One more check if we haven't broken anything. So let's go back to our Wally crawlies. And yeah, I'm liking it. Can you shoot these guys? All right. Let's take this last minute to change the edge reached functionality a little bit, so that we don't have the pause when these robots are switching their direction when they hit their head in the wall. Because I think we can fix that in the is edge reached method. Because we are already at the correct column that we want to check. We just have to check an additional row. So what we'll do is we'll just calculate the actual row here, and we'll keep a boolean that says like, you know, the edge is reached that if we either reach a pit or if we reach a you know, a wall, a solid wall. So blocked, I guess, should be the thing. So blocked is if the state get level is solid for our current row and our next column. And the pit is reached if the tile beneath that is not solid. So get level is solid row +1 +1 next column. And then if we are either blocked or pit reached, we should flip around, because then the edge is reached. So let's see, now they should bounce around a bit faster after hitting the wall. And we can see now that is looking a lot better, a lot more smooth. And I think we can do a similar extra check for these wall crawlers here. Because I think if they reach the bottom here, I think they also wait for a split second. But because they update each frame, it's not as noticeable. But let's just also do it there. So the next row is always correct. And the column as well. Apart from, of course, we want to check the column in front of us and not beneath us, or like where our feet are going to be. So again, here the 1 or -1 thing is just something that we need to add for ourselves when we do the. So let's see, boolean blocked, and then boolean, I don't know, pit. I guess we can just do the same. So here we have the pit thing. So blocked or pit, and then blocked is state get level is a solid next row call, and then the column that we want to check for the block check is just our regular column, but for the pit we want to add either one or subtract one depending on where we're facing. And now these wall crawlers should also instantly flip around and not rely on the collision detection. The collision detection is still there. But now they should move up a bit more smoothly. But like I said, it's just one frame, so it's really hard to notice. That is a nice wrapping up of this episode. We've added in the wall crawler and used the lessons learned from this wall crawler to make the techbot a little more concise and have somewhat the same logic. And the reason for this is that next episode we will implement the tank robot, basically. Let me see if I can find a picture for you. We'll implement this guy here, because this guy also patrols from left to right. It has a little bit more health and it actually shoots back. But that means that we now have, next episode, 3 patrolling robots. So finding some shared functionality between them will enable us to write one superclass that controls the patrol behavior, and it should make it easier for us to add these robots. We'll do that in the next episode. So for now, I want to thank you very much for joining me. If you have any questions, feel free to add them in the comments down below. If you like the series so far, then please drop a like or a subscribe. And I'll see you guys in the next one. Bye-bye.